So its input is the starting vertex, and n is the number of vertices in the graph. And what is the output? Output is the visited array uh, that gives the order of the vertices that are scanned during the traversal. And so first, copy these 3 lines. So data structure, here the data structure used is Q. Q data structure is used, okay? And let the Q name is open queue that holds the vertices visited. Initially, it is empty, okay? And initially it is empty, and GPTR, and let GPTR is the pointer to the graph. Okay, GPTR is the pointer to the graph. Same here, GPTR is the Am I audible?
Yes, sir.
Yes, sir.
Yes.
Okay. So in BFS, the data structure is Q, and let the Q name is open queue that holds the vertices that are visited. Initially it is empty, and GPTR is the pointer to the graph. Okay, GPTR is pointer to the graph. Okay. Now the algorithm is if the GPTR is null, then print the graph is empty and exit. Okay. Otherwise, U is equal to V. Okay. That is V is the starting vertex of the graph and it is copied in the U. Then open, then open Q. Open Q is the name of your queue and this will be NQ. Open Q, NQ. That is enter the starting vertex, enter the starting vertex in the into the open queue. Okay. And while your open queue, status its status is not null, that is not empty, then that is till the open queue is not empty. Okay. So U is equal to it is stored open queue dot dq. Okay, that is delete the delete the item, delete the element from the open queue. Okay. Now, if your search array, line number 9, if your search array, visited U is false, then that is your U is not in the array visited. Then we have to first insert the U in the visited array. Okay. Insert U in the array visited. Right. Now for I is equal to 1 to n, for I is equal to 1 to n, what should I do? So enter the adjacent vertices, of U into open queue. Okay. And if GPTR UI is equal to 1, then open queue, and it will be NQ. Okay, that is enter the vertex I into open queue. Okay, and end if, end while, end visited, and stop. So this is your breadth first search algorithm from line number 1 to line number 19. I will explain it with the example. Do you have any question, any queries? Please clarify. These are the algorithms. This is your breadth first search algorithm, BFS, breadth first search algorithm. It uses the queue data structure. The queue data structure is used here. And this is your depth first search where stack is used. Any question? Anyone? Is it visible?
Yes, sir.
Yes, sir.
Okay. So, one example. Let the graph is let the graph is denoted in this form. Let this is your vertex M, okay, and this is your vertex R, then N, this will be let Q and P. Okay, so this is your graph. The graph is given to you. Okay, now actually get 2008 and it repeats in 2017 also. It appears 2 times in get. So apply the breadth first search. Apply the BFS. So any idea? Anyone please? Let P is the starting vertex. How should I proceed?
Firstly, P will be inserted in the open queue.
Okay. So Q. Here BFS is used. That's why Q data structure will be used. So this is your open queue. This is your open queue data structure. Okay, and this is your array visited. This is your visited array. Okay, so first P is inserted, right? So first P is inserted in the queue. So if your GPTR is not null, print the graph is empty. So line number 1 to 4 will not be executed. Line number 5, V is the starting vertex. V is the starting vertex. Here in our example, P is given as the starting vertex. So P is copied in U and open Q in Q P. That is P is inserted. Now, if its status is not null, that is your open queue is not empty, your open queue is not empty, then first dequeue, the element and store it in 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 another variable. Also you can use another variable. It may be small x. Then you have to search that particular element, that is search array visited x, if it is x. Okay, if it is false, that is your x is not in the array, then insert your x or u in the visited array. So first of all, your visited array is empty. Okay, so first write down P here. Okay, write down P here, and next, if GPTR UI is 1, that is its adjacencies. So its adjacencies. So first remove this P and insert that P in the visited array. So what are the adjacencies for P?
O and Q.
O and Q. So O and Q, you can take it arbitrarily.
Yes.
So let this is O and next one is Q. O and Q. O and Q. Next again, open Q, NQI. So NQI.
O and Q are enqueued in open.
So P is scanned. Next O and Q. These are inserted, right? Starting from P, we are getting O and Q. You can write Q and O and Q in same order. Okay. Next, which one will be deleted first?
O.
O. Yes. So O will be deleted. Why? Why O? Because
This is Q and the
this
first
is Q
element
data
will
structure.
get
Yes,
first.
this is Q data structure. For Q data structure is called LIFO or FIFO.
FIFO.
FIFO, first in, first out. So Q
FIFO.
is entered first, so Q will be deleted first. Sorry. O is entered first, so O will be deleted first. So first delete this O. Okay, so first delete this O and write down your O here. So O is visited, right? Now adjacent of O, adjacent of O, adjacent of O,
N and Q.
N and Q. So N and Q. N is Q is already there. That's why we have to write N. Okay. Next, which one will be deleted?
Q.
Q will be deleted. So delete Q. So delete Q and insert Q here. Next, which one will be executed?
M.
M.
And
M and Q. So Q is already there in the visited array. That's why M. M is written in the open queue. Okay. So pop, actually delete this N. Delete this N here. Next, from M we are getting R. So delete this M and write down M here. And finally write R. So this is the breadth first search. This is the breadth first search of the given graph. This is the breadth first search. So POQ NMR. POQ NMR. Is it clear to you?
Yes, sir.
Any
Yes, sir.
queries? Any queries?
no,
স্যার আপনি যে স্টার্টিংটা পি থেকে করলেন এটা কি কোয়েশ্চেনে দেওয়া থাকবে নাকি যে কোনো কিছু একটা স্টার্টিং আমাকেই ধরে নিতে হবে?
It is given in your question.
ওকে স্যার।
Okay, let কে কোশ্চেনটা কে করেছিল?
স্যার আমি
আমি কে?
শ্রীময়ী।
Let Q is the starting vertex. Then what will be the visited array? Instead of P, Q is the starting vertex. Any idea? Now execute your BFS algorithm, your breadth first search algorithm, starting from Q. So first, what should I write? How to proceed? Anyone? Srimoy?
ইয়ে স্যার ফার্স্টে তাহলে ওপেন কিউতে ফার্স্টে পি থাকবে ও থাকবে আর এন থাকবে আর এম
First,
থাকবে পরপর
first Q is written. First Q is written in the open queue. Okay.
ইয়ে স্যার
Okay. Then explore the queue. Explore the queue. So first Q is copied in U, then enter the queue, that is U here, in the open queue, and while your queue is not empty, so first delete that particular queue and search. If your queue is not in the array, then insert your queue, and then starting from 1 to n, find out the adjacent vertex of your previous queue. Okay, that is gptr ui is equal to 1. If it is 1, then immediately enter that I, then again find out the adjacent of that entered I, and so on and so forth. So first q is entered in the open queue. Okay, so write down q here, q in the visited vertex. Okay. Then adjacent of q are
P O N M.
you can take it arbitrarily. Okay, so
Yes, sir.
we can take m and then n, mn, next one is op, mnop. Okay, right? Now what is the next deleted vertex?
M.
M. So write down m here and delete that m from this. So which one will be entered?
R.
R, because m is now explored. Adjacent of m are n, q and r. Q and n are already in the visited array, so r is written in the open queue. Okay, next one is, which one will be executed?
N will be executed.
N.
N will be executed. N will be executed. Okay, N will be executed, and from N we are getting Q and O. Already Q and O are explored, so delete that N. Okay, next one, O, right? From O,
Yes, sir.
so from O we are getting N, Q and P. Q is already visited, P is there in open queue, and N is already in visited. So write down O here.
Sir, will P be inserted again?
So next, no. If it exists already in visited, it will not be executed again.
So P does not exist in visited, it exists in OpenQ. So maybe it will be inserted in OpenQ once more.
When?
Sir, when we are considering O,
Hmm.
so in the condition if GPTR of UI equals to 1,
Hmm.
there I think P will be inserted in OpenQ. In the OpenQ, I think P will be inserted one more time because it's not in visited, so we
When
can't check.
when O is there, then from O we are getting N. N is already in visited. Q is visited, and P. Yes, P is inserted again. Right? P is inserted again. Next, next one is P. So P from P we are getting O and Q. Already O and Q are in visited. So write down P here and delete that P. Next R. R is not in your visited. So from R, we are getting only M. M is in visited. So write down R. Okay. So delete R from this open queue and P is there. So P already in the visited, so left it. So this is the traversal. QMN OPR. Is it okay?
Yes, sir.
Okay. Now find out the um, find out the DFS. Find out the DFS of this given graph. Find out the DFS of this given graph. Let P is the starting vertex. How can I proceed? Anyone, please?
First, P will be inserted in open.
আচ্ছা ফার্স্টে ক্লাসের ফার্স্টে একজন কোশ্চেন করেছিল না যে এক্সপ্লেন
Soham.
করতে হ্যাঁ সোহম
Soham.
Yes, sir.
ডিএফএস কিভাবে এক্সিকিউট করবে সোহম
Sir, first of all, we'll put the starting node in the top of the stack.
so starting node is here let this is your visited so starting node is P okay your starting node is P so P is inserted next P is inserted and then unless and until your stack is not empty pop the topmost element and if your topmost element is not in your visited array then insert that particular top element in the array and for I is equal to 1 to n for I is equal to 1 to n if your top element its adjacent are 1 then push and accordingly pop and search so first P so P is not in the given array so write down P here next P is popped so P is popped so what should I write any
O
answer
and Q.
O and Q both this is the difference between BFS and DFS in BFS breadth first search we are using the queue so one particular nodes so consider one particular nodes all adjacents okay In case of depth first search, you are using the stack.
Sir, we are running a loop here too. So I think
So you,
it's the same thing, just we are pushing and in that we are enqueuing. But we are running a loop here too, we were running a loop there too. So I guess
so
both will
O,
be
so first O,
then Q.
then Q. Next one,
So then Q will be popped this time instead of O. In breadth first search it was FIFO, this is LIFO. So Q will be popped.
so Q will be popped. And from Q,
We get O
Right.
and M.
N, Q, and P. P and P is already in visited, and Q is visited. So N, sorry, N and M.
In M.
So N is writing here and M. Okay, N and M. And next, কি হবে?
Sir, M is popped and we move to R node.
M is popped. M is popped. And adjacent of M, that are Q, N, and R. So write down R. So write down R. Okay. Next, R will be popped. R will be popped, and no other vertices there for scanning. So N and next O. N and next O. So pop this in and O. Now is it clear?
Yes, sir.
So this is for depth first search, DFS, visited array, and these are the BFS visited array. Okay. Let another example. ABD, from B we are getting C. Let this is your C, and this is your E. This is let F. Let A is the starting vertex. Let A is the starting vertex. Just find out the BFS and DFS. The depth first search and the breadth first search. This is the array for DFS and this is the array for BFS. Can you find out?
Yes, sir.
Yes, sir.
Okay, so do it. So first do the depth first search. So A is the starting vertex, okay? A is the starting vertex. So what should I write first? A. Write down A. And just write A in the visited array. Next, from A, we are getting, pop this A. So from A, we are getting B and D.
Yeah.
B and D. So write down B and next D. B and D. Okay. Next, from D, next কি করবো বলো তো?
E and G and E.
G and E. So from D, now explore D. Because D is the topmost element. So delete this D here first and check whether your D is in the visited array or not. Yes, not. So that's why put this, put your D. Okay. Right. And next one is
GE will be inserted in the stack.
GE. So G and E will be inserted in the stack. So first A is visited, next D is visited, okay, and then after E, so E will be popped out. From E we are getting G, F and C, G, F and C, okay. So what should I write? First omit this E and write down this E here. And from E, we are getting F, C, FC. Should I write the G?
Sorry,
Prabhakar,
sir. Yes, sir.
should I write the G?
So like G should be inserted, but even if you insert it, it doesn't matter because at the end
Okay,
visited, when we check for visited,
okay. So
it will.
E is inserted. Next, you can ignore it also. You can ignore it also.
So that's what I was saying.
So last element is C. Last element is your C. So from C, you are getting, so delete first C. So first delete your C. So E is complete. E is complete. Okay. Next, F and C. So first write down C. So which one will be popped? C will be popped. because C is the stack top. So write down C here. So C is scanned. Okay. C is scanned. And next, from C, we are getting F. So just omit this F and write down here, or F. Okay, so from F we are getting G. G is already in this, so ignore this and write down this G. Write down this G. Next, B is there in the stack. So omit this B and write down B here. So AB, so what is the actual traversal? From A, next B, next E, next C, from C, F, then G, and from this last element is your B. So this is your depth first search traversal. Any query?
No, sir.
Okay, and you can convert it. Now convert this graph in the DFS, sorry, BFS, breadth first search. So what will be the output?
So it depends on how we choose the elements. Totally. Like,
Yes, it may vary from student to student, but the selection should be correct. Okay. So this is from again 2008. Get 2008. Okay.
sir, in gate it will be MCQ, right?
Yes. Four options
So,
will be there. Four
so
options will be there, and
yeah,
from four options you have to choose the correct one.
yeah, sir. So it may happen that some student does it in a different way, so he may get a different answer than the
There
answer given in the options.
no, there will be only one correct answer.
Yeah, one correct answer, but that correct answer may not be the answer of the student. So, like,
So in DFS and BFS, there are more than